All right, folks, it's the frame of a crate. It's made up of 12 steel rods, and here they are. So there's got 1, 2, 3, 4, then 5, 6, 7, and 8, then 9, 10, 11, and then 12. So each of the rods makes it up. Rods are of different lengths. But to show the length of the crate will be L on 9 centimeters when the volume is a maximum. So we're not after an exact answer so much as we are an expression or equation that makes this work. So first of all, let's have a look and let's define this in terms of the length of things. So if I look at the width here, we've got 1, 2, 3, 4. 1, 2, 3, 4 widths. Yeah. So we're going to have, if you like, L, the total. It's going to have 4 of those. It's going to have 4 lots of X. Then here we've got 2 X's, yeah? We've got a 2X and a 2X and a 2X and a 2X, yeah? So plus 4 lots of 2X, plus we've got height 1, 2, 3, and 4, plus 4 lots of height. We don't know what height is or the X's are either, so let's go and put this together. So we've got 4x, and that's going to be 8x, it's going to be 12x plus 4h. So that's all well and good. And what we want to do now is put that in terms of h. So L, I'm going to subtract some bits here. So let's subtract 12x from both sides. Here it is, minus 12x, because I want to put this in terms of h just for a moment here. So I've got L minus 12x is equal to 4h, and if I divide both sides by 4, I get h is equal to L minus 12x on 4. And the reason I want to do that is because I want to come up with an equation for the volume. And the volume, of course, is equal to length times width times height. We know what those are mainly, but height's going to be this one, and height has to be in terms of x, otherwise it makes it a bit difficult to differentiate it, to find the maximum. So the length, well, we know the length is going to be 2x, the width is going to be x. So I've got length 2x times the width, which is x, times the height, which is L minus 12x. So I'm just going to put a line straight down here now, because I know what's going to happen, given the way I have to take up space to do this. Oh, W, we know W is x. What am I doing? So let's put an x in there, yeah? There it is. So this is going to equal 2x squared times, that's on 4 as well. Yeah, that's going to be L minus 12x on 4. Well, of course, 2 and 4 goes in. X squared on, I'll put L over 2 minus 12 over 2. Yeah, I think that's probably a better way of doing it, because this is now 2, you see, because I've just divided that by 2. Okay, let's expand that out. So I've got Lx squared on 2 minus, this is going to be 6x, yeah? This is going to be 6x, and x times x squared is going to be x cubed, yeah? And that's my new expression, yeah? Lx squared on 2 is equal to x cubed. So that's all well and good. That's fine. I like that. Now let's go ahead and differentiate it. So if we differentiate that, so differentiate volume with respect to x, that's going to be 2Lx on 2 minus 6 3s are 18x squared. Of course, 2 divided by 2 just leaves me with an Lx. So Lx minus 18x squared. And I'm going to make this whole thing equal to 0. We want it to be equal to 0, because we're going to find it when it's a maximum. So it doesn't help us all that much. We're looking at it, but we want to find, we want to get to this equation here. So when would that be true? Well, let's go ahead, and if I was to add 18x to both sides, so I've got Lx is equal to 18x squared. So if I divided both sides by x, divide by x, and that goes like that. So now I've got L is equal to 18x. So I've got L is equal to 18. Where was it? I got is equal to 18x. That's what I said, 18x. So what we want to do is say, well, what's x equal to? Well, x, if I divide both sides by 18, x is equal to L on 18. There it is. But the question says the length of the crate will be L on 9, and we've got L on 18. But that looks good because it's not x we're after. The length is 2x, yeah? Show the length of the crate. The length is 2x. So I'm going to multiply this by 2, and I'm going to multiply this by 2. Because 18 on 2 on 18 can be simplified as 1 on 9. So 2x is equal to 1 on 9L. So x, so 2x, or the length, if you like, 2x, the length, what length here, is equal to L on, L on 9, and that's what we're trying to show. So that's how I'd go ahead and do that. A bit messy in some places. And it wasn't clear I was actually getting closer at this point. But I think once we start, we make it equal to 0, we're finding it for a maximum, and then suddenly it all kind of pops out, and we can find the bit we're after. So 2x, the length, and you've got to go back and remind yourself, because I get x is L on 18. I'm thinking, well, hang on, we want L on 9, but the length is not x, the length is 2x, and that's the key. So that's how I go ahead and do that. Hope that makes sense.